video, I will discuss to you all about efficient sections. This is Devine Grace the Idala of Bsce 4A. During the design stage of an open channel, sectional area, roughness, and slope are given. The objective is to determine the flow velocity, depth, and flow rate. The designs of channel involves selecting the channel shape and bed slope to convey a given flow rate with a given flow depth. The efficient sections, also known as economical sections, these are sections which, for a given slope, channel cross-sectional area, and roughness, the rate of discharge is maximum. Fermaning formula, Q is equals to A times 1 over N times R raised to 2/3 times S raised to 1/2, where Q is the discharge, A is the cross-sectional area, N is the value of manning roughness, R is the radius, and S is the slope. It can be seen that A, N, and S constant. Q is maximum when the hydraulic radius R is maximum. And since R is equals to area over perimeter, then R is maximum if P is minimum. The section of a channel is said to be most economical or efficient when the cost of construction of the channel is minimum. But the cost of construction of a channel depends upon the excavation and lining. So, to keep the cost minimum, the width perimeter for a given discharge should also be minimum. In order to further understand the statement, suppose that you are required to design a rectangular canal to have a cross-sectional area of 8 square meter. The possible dimensions, width times depth, are shown. Of the shown dimensions, it can be seen that the size of 4 meter by 2 meter has the least perimeter, hence it is the most efficient. Efficient sections include rectangular section, trapezoidal section, triangular section, and circular section. Proportion for most efficient section. To derive the proportions for most efficient sections, minimize the perimeter with the cross-sectional area constant. This is the derivations of proportions for rectangular section. It is clear that the rectangular channel will be most economical when either B is equals to 2D or R is equals to D over 2. For trapezoidal section, take note of these derivations of proportions. The most efficient trapezoidal section, including the rectangle, has its top width x equal to the sum of the sides 2y, which is a proportion for a half hexagon. This shows that best of all efficient trapezoidal section is the half regular hexagon, which means all sides are equal. This is the derivations of proportions for triangular section. It can be seen that the obtained value of theta shows that the most efficient triangular sections is the 90-degree V-notch. And lastly, for circular sections, a circular channel will have its maximum discharge when the depth of flow d is 93% of the diameter d and the velocity is a maximum when the depth is 82% of the diameter. Now let's have sample problem number 1. A trapezoidal channel has a bottom width of 6 meter and the side slopes of 2 horizontal to 1 vertical. If the depth of flow is 1.2 meter and the flow is 2.40 cubic meter per second, compute the slope of the channel if n is equals to 0.014. Given in the problem, Q is equals to 20.4 cubic meter per seconds. Get the value of A, which is equals to 10.08. By using the formula V is equals to Q over A, the value of V is 2.0238 meter per seconds. By using Manning's formula, substitute all the solved values so the values of slope will be computed. The slope is equals to 0.0094. That's all for sample problem number 1. In this part, let's have sample number 2. A rectangular concrete channel 155 meter wide is to carry water at the rate of 22 cubic meter per second. If the channel slope is 0.0025, determine the normal depth of flow. Use roughness coefficient n is equals to 0.013. Use Manning formula and substitute the given value. By simply through trial and error, we obtain the value of normal depth, which is equals to 1.187 meter. That's all, and hope you learned something about efficient section.